Hello, students. Good morning. I hope you all are safe and healthy at your home. Welcome in lecture number 14, paper IC-10, unit number 3. In previous lecture, we start biogas plant for use of biomass. Now, in this lecture, we continue the second plant. And second type of biogas plant is batch type biogas plant. First we saw continuous type, and in that lecture we classified continuous in two types, single digester and double digester. Now in batch type biogas plant, the feeding is done between interval and the plant is empty. In continuous, there is feeding and output are continuous process. But in batch type, feeding is done, then acidogenic and methanogenic process takes place. We get gas, and then after we empty the plant. Now when complete empty the plant, then we feed the second time. So the feeding is done between interval and plant is empty. Such type of this batch type is shown in this figure. Once the digestion process is completed in this type of system, all type of digesters are charged along with the sludge and are allowed to produce methane gas for a period of 40 to 50 days. In this type, there are gas production period is 40 to 50 days. In continuous, there are 3 to 4 days required. But in this type of process, the production of methane gas and carbon dioxide for 40 to 50 days. They are applied in similar manner, and thus by connecting series of plants and continuous supply of gas is also possible. If we arrange this type of system, or I show this type of single stage process type material, this type of arrangement is also known as batch type arrangement. In first figure, the output material is charged into second, and second's output is charged into third, and we arrange this type of digester continuously. And for continuous gas production, we get gas continuously in batch type of arrangement also. Features of batch type biogas plant. The gas production is intermediate and depends upon cleaning of digester. First of all, we discuss the batch type, and in this discussion we show the gas production is step by step. First of all, material charge, then process takes place, that is acidogenic and methanogenic, and then gas produced. We use this gas and then clean the digester. Now second batch is charged after the cleaning of digester. So gas production is intermediate and depend on cleaning of digester. This system requires several chambers for continuous gas production. In second or third figure, if we arrange continuous gas production, then several chambers are required. Number 3. Suitable for long fibrous material. Here, gas production time is 40 to 50 days. So, long fibrous material is also converted into small chain materials. While in continuous type, it is not suitable for long fibrous material, but this type of batch type of biogas plant is suitable for long fibrous material. And last, number 4, plant is more expensive and problems associated are more. Here we get process step by step. So this type of plant is more expensive and problem associated are more. These are the main features of batch type biogas plant. Now, number 2, main classification of number 2, that is dome and drum type biogas plant. Dome and drum type biogas plant. Numerous models of biogas plants are mainly based on number 1, floating gas holder plant, that is known as KVIC, Khadi and Village Industrial Commission. Full form of KVIC, Khadi and Village Industrial Commission. Therefore, it is also known as KVIC biogas plant or floating gas holder biogas plant. And number 2 is fixed dome type biogas plant. It is also known as Chinese type biogas plant. So, on the basis of dome and drum, there are two types. Number 1, floating and fixed dome. Floating type gas holder plant and fixed dome type gas holder plant. Let us see both one by one. First of all, we see KVIC biogas plant, Khadi and Village Industrial Commission biogas plant. Here, a sketch of biogas plant is shown is KVIC biogas plant. We see the construction. The plant consists essentially two parts. The digester, which is a wall containing the animal waste and form a slurry, and the dome, which float on a slurry and serve as a gas holder. This is also the second figure. The digester is normally below ground level and two pipelines lead to its bottom, one for feeding animal waste slurry and other for spent slurry called sludge to come out after it has undergone fermentation. In this figure, we show the first is this, which feed the animal waste material as a slurry. First of all, in mixing tank here, all materials are fed with the help of water. So biomass and water mix and it is in form of slurry. Now this slurry is input by this type of pipe. This is the wall which separates the biogas plant in two parts. Now this slurry is fermented and after fermentation the material which is we get after fermentation it is out by this pipeline. It is called outlet pipeline. I show here, this is outlet pipeline, and the solid material after formation of methane gas is known as sludge. It is very good fertilizer and used in farming process, and the gas which produce is stored in floating type dome. This dome is flat on the slurry, and production of gas, the produced gas is stored in this type of plant. Typically the feeding is done regularly once a day. The sludge come out with the buildup of gas pressure in dome. When gas is produced and this gas is build up the gas pressure, then the dome is up and down, and the inlet valve for the gas is here. I show in figure, the inlet valve for gas is arranged here. So when gas is produced, then it build up pressure on this type of dome. So dome is up and down, and produced gas enter in the storage tank or a dome. It is worth nothing that the sludge retains the nitrogen, phosphorus and potassium originally present in the animal waste and is an excellent fertilizer. After production of biogas, the sludge material contains nitrogen, phosphorus and potassium, and these three elements are very useful in farming process. So sludge is excellent fertilizer. The diameter of the digester ranges from 1.2 to 6 meter, while its depth ranges from 3 to 6 meters. I show the figure, you get exact idea the diameter of digester and depth of the digester. A vertical partition wall divide into two equal parts and serve to direct the flow of slurry. So partition wall is required. The calorific value of biogas ranges from 16,000 to 25,000 kilojoule per meter cube. 16,000 to 25,000 kilojoule per meter cube. Now we see the advantages of KVIC or floating drum type biogas plant. This described figure is also a KVIC, standard KVIC biogas plant. We discuss advantages and also it has some disadvantages. So we discuss both advantages and disadvantages. It has less scrum trouble because solids are constantly submerged. Here also we input the slurry, so scrum troubles are less. Number 2, no separate pressure equalizing device is needed and fresh water is added to tank or digested slurry is removed. This is main important point. Here no pressure equalizing device is required. Separate pressure equalizing device is not required and fresh water is added, so the inlet material is in form of slurry and we remove this slurry very easily. Number 3, danger of mixing oxygen gas with explosive mixture is minimized. Here we see the arrangement. The digester is below the ground level, so the oxygen mixing of oxygen is less, and then the explosive mixture is minimized for the danger symptoms in this type of plant. Number 4, high gas production per centimeter cube of digestive volume is achieved. It is very important point. Advantage is high gas production per centimeter cube of digestive volume. And number 5, no problems of gas leakage and constant pressure of gas exist. It is also very important. Gas leakage and constant pressure, no problem of gas leakage because of it is constructed under the ground level and we get constant pressure in methane gas. These are the main advantages of KVIC type biogas plant. Now we discuss disadvantages. Disadvantages of biogas plant. Here described figure is real biogas plant figure. The main part you see in this figure, this is the floating type gas storage or a floating drum which is float on slurry, and digester is in the ground level, below the ground level. So the digester is below the ground level and the drum or float is on this. We see the disadvantages of floating drum type biogas plant. Number 1, high cost. Production cost of gas is high and construction cost of this type of plant is high. So it is not suitable for everyone. Number 2, leakage of heat to metal glass holder. It is very important. Leakage of heat. We saw advantages in leakage of gas is no problem in this type of plant, but here heat leakage is because of gas holder is made up of metal, so it absorbs the heat and leakage of heat gives some problems. Number 3, not suitable for or colder places. When the temperature is down, the colder place where leakage of heat is main problem. So this type of KVIC, Khadi and Village Commission Biogas Plant, KVIC plant is not suitable. Number 4, flexible piping joining gas holders for the main gas pipeline. And number 5, requires maintain and it is easily damaged due to rotation or twisting. Rotation or twisting of earth is continuously and our digester is below the ground level, so it is easily damaged due to rotation and twisting of earth, and earth continuously rotate around the sun. So we do not know about the damage, easily damage of digester, and then for digester is damaged in ground level, so leakages of gas is also associated in this type of biogas plant. These are the main disadvantages of floating drum type or KVIC biogas plant. I have some videos of this type of biogas plant. We see this type of biogas plants video in next lecture. Thank you.